In 1.5, we're going to multiply polynomials. This is the last lesson in this unit, and we're going to be putting a lot of our ideas together. First, I want to review with you the difference between repeated addition, which is multiplication, and repeated multiplication, which involves exponents. So a problem like 2x plus 3x, you saw this in the last lesson, and we know that we can just add the numbers that are in front because these are like terms. By like terms, we mean the same variable raised to the same power. Multiplication is repeated addition. So if I have 2 times x, then that is just x plus x. If I have 3 times x, then that's x plus x plus x. And if I add those two groups together, then you can see that I have 5 terms of x, which is 5 times x. 5 times x is repeated addition. Now when I have exponents, exponents indicate repeated multiplication. So if I have x squared, then that's x times x. And if I have x raised to the third power, then that's 3 factors of x, like this. If I multiply those two groups together, then you can see that I have 5 factors of x, which I can write as a shortcut x to the 5th. Instead of expanding the multiplication, I can just count up my exponents, add my exponents together to get that ending exponent when I'm multiplying. So exponents only change when you're multiplying. Coefficients change when you're adding. Write down this first example. We have a monomial, which is 5x, that's multiplied by the polynomial or the binomial x plus 3. Now this is very similar to the last lesson where we were using distributive property. The difference is that I have a variable on the outside with my 5 that gets distributed through the group. That means that our exponents are going to change in this problem. But what stays the same is I'm just distributing the 5x to both of the terms inside the group. So 5x times x is 5x squared. I'm multiplying, so the exponent changes. And 5x times 3 is 15x. And that's my final answer. Those are not like terms because the exponents are different, so I can't simplify any further. In the next example, I also have a monomial on the outside. I have 3 terms inside the group. It doesn't matter how many terms you have to multiply what's outside the group times each of your terms inside the group, like this. So 2x cubed times x squared is going to be 2x to the 5th power, because 3 factors of x times 2 factors of x would give me 5 factors of x. That repeated multiplication changes our exponent. And then we go to the next term. 2x cubed times 7x is 14x to the 4th power. Remember, there's an understood power of 1 on that x. And then 2x cubed gets multiplied by negative 5, so that positive times negative is going to be minus 10x to the 3rd power. Notice how I took the minus sign as a negative on that 5, and that kept my signs correct in my answer right here. We can also multiply groups together, so instead of a monomial times a polynomial, maybe we have a binomial times a binomial, or a binomial times a polynomial. So we really need to keep our information organized, and I like to do this in a box. There are other methods for organizing your work, and as long as you find something that gives you the correct answer, then that's fine. Notice we know we're multiplying these together because these parentheses right here are next to each other. There's not a plus or a minus in between there. I have to multiply every term in the first group times every term in the second group, which is why this box can be helpful. So I'm going to put my 2x and my plus 3 on each column and my 5x plus 1 down the side. Now you could switch the order of that because multiplication is commutative, so we can change that order. Now we're going to multiply what's on the outside and fill in the box. 2x times 5x is 10x squared. 3 times 5x is 15x. 2x times 1 is 2x. And 3 times 1 is 3. Now we want to give our simplest answer, and so we're looking for like terms. We have to add up all the terms that are inside the box, and I can see right here that these are like terms. So I can combine those as I write my final answer. I have the 10x squared. I'm going to add to that 15x plus 2x, which is 17x, and then plus 3. Remember, I was multiplying to fill in the box, but then I'm adding those terms that are inside after the multiplication is done. Now pause the video and try this next binomial times binomial, and be very careful with those minus signs. Take them with the numbers as negatives. Be sure and check your answer. If your answer does not agree with mine, then make sure you check your signs. I took that -1, I took that as a -1, and so that negative times positive gave me a -2y, and then I have a -9y in this box, and those are my like terms that give me that -11y in the middle. If you have bigger polynomials, then you just need a bigger box. Remember to look at the parentheses. You're only multiplying if those parentheses on the inside are right next to each other. If there's a plus or a minus in between there, then that's a different type of problem. It's like our last lesson. But if the parentheses are next to each other, we're multiplying. So maybe we'll organize our work in a box. So I'm going to put the 2x plus 1 down the side because I have 2 rows, and the x squared plus 6x minus 4 across the top. I'm going to multiply to fill in the box. So 2x times x squared is 2x to the 3rd power. 2x times 6x is 12x squared. I'm multiplying, so my exponents are changing. -4 times 2x is -8x. X squared times 1 is x squared. 6x times 1 is 6x. And -4 times 1 is -4. Now that I've filled in the box, my multiplication is done, and I'm just combining like terms to simplify. So I don't see any other x cubes, but I see that I have x squares on this diagonal, and I have x's on this diagonal. So I'm going to combine those to get my final answer. I like the standard form where the highest exponent, largest exponent is first, so 2x cubed. 12x squared plus x squared is 13x squared. And then -8x plus 6x is -2x. And then we just have our -4. So don't leave any of your terms in the box. Either combine them or make sure you write them down separately. Take the time to pause the video and work through this next example. I really encourage you to use the table to organize your work. Make sure that you draw your box big enough that you can read what you write inside of it. So most of the time people draw the box too small when they're getting started. So draw a big box. So here's my final answer, and make sure you check your answer. Our like terms were not on the diagonal this time. They were kind of separated, and the only like terms we had were the x squared terms. So that -3x squared and -4x squared is where the -7x squared came from. And other than that, you're just listing those terms, and again, standard form where the highest exponent is first, and then counting down as the exponents get smaller. Remember, if you have questions about this, you should ask your teacher, you should ask a classmate. Perfect squares happen when you multiply a number by itself. So if I have 1 squared, that's 1 times 1, which is 1. 2 squared is 2 times 2, or 4. 3 squared is 3 times 3, or 9. 4 squared is 4 times 4, 16. 5 squared is 5 times 5, 25. And of course we could keep going forever. Binomials, or any polynomials, can also be perfect squares. Usually we're talking about perfect square binomials, and here's an example of one. Make sure you write this down. If I have 3x minus 6 squared, then that power on the group, that exponent on the group, means the same thing that it means on a number. It means that I'm going to use the group 3x minus 2, or minus 6, as a factor 2 times, like this. And then this turns into a double distributive property, or drawing a box and multiplying this out. So we would get 9x squared, and -6 times 3x would be minus 18x. These are the terms that would be in your box. You have another negative 18x, and then you would have a plus 36. And then when we find those like terms in our box, these would be on the diagonal. And so our final answer here would be 9x squared minus 36x plus 36. And you will see on binomials that are perfect squares, you will see some of those perfect square numbers, especially on the ends of that result. Now, something that looks kind of the same but is not exactly the same is the difference of squares. And what you should notice here is that one of these groups has a plus in between and the other one has a minus. But other than that difference, they look exactly the same. We know that these groups are multiplied together because the parentheses are next to each other. So let's go ahead and put this in a box. We have an x plus 5 multiplied by an x minus 5. X times x is x squared. 5 times x is 5x. Negative 5 times x is negative 5x. And 5 times negative 5 is negative 25. So again, we have some perfect squares. When we combine our like terms on the diagonal right here, they cancel out because 5x and negative 5x, they're opposites of each other, so they zero out. And what's left for our answer is just the x squared and the minus 25. So when we have the difference of squares, we end up with just two terms like this. And you'll see that pattern over and over. It's good to pay attention to it. What happens if we have polynomials multiplied together, but we have more than one letter in our polynomial? Well, let's try it and see what happens. I'm just going to put this one in a box. And it's a 2 by 2 box because it's a binomial times a binomial. So I have 2r plus p, and then I have r minus 3p. Let's multiply like we did before. So we have 2r times r is 2r to the second power. R times p is just r times p. Or you could reverse that order, p times r, it doesn't matter. When you multiply 2r times negative 3p, we're going to get negative 6 for the number part. And then r times p, or p times r, I'm going to write it r times p because that's the same order I had on the other one. And we know by commutative property that we can write those factors in any order. Now let's multiply p times negative 3p, and that gives us negative 3p squared. So remember how we had those like terms on the diagonal in the other box? Well, we have that here as well because we have exactly the same letters raised to the same power. It doesn't matter that there are two different letters that are multiplied together. So we're going to add those. We're going to combine those like terms. First I'm going to write the 2r squared. And I have negative 6rp and a positive rp, so that's going to be negative 5rp. Remember, there's an understood 1 right there, if that helps you to figure out that arithmetic. And then we have minus 3p squared. And that's okay to have more than one letter when you're multiplying together. Pause the video to work on these next 3 problems and then come back and check your answers and your work. No, really. Pause the video and work them on your own. Then come back and check. Alright, now you can check your answers. This is a very important skill that you will be using all year long, and you need to be able to do it without mistakes. So make sure you practice, practice, practice. Let me know when you're ready for your mastery check on 1.5.